All right, here we go. Moving on with some more probability. Today we are going to be talking about compound events. Compound events means you're talking about two events that can happen and you're looking at all the possible outcomes of it. So the two possibilities we could have are disjoint, which means they have no common outcomes, nothing in common, such as rolling a die and picking a card from a deck of cards. One has nothing to do with the other, and then the other is overlapping, which means basically two things have something in common, such as drawing a card from a deck and drawing a spade or a face card. So since there are cards that are both spades and face cards, you can't count those twice. So that's what overlapping means. We'll look at some examples of how that works. All right, so first thing we want to think about is whether something is disjoint, meaning they have nothing in common, or overlapping, which means they do have something in common. Okay, so the first one here, the first event that we're looking at, is that you roll a die and you get an even number. And the second one is when you roll that die, you get a multiple of 3. So you're thinking about your possibilities here. You've got on a die, the even numbers are 2, 4, and 6. Okay, those are the even numbers. The multiples of 3 would be 3 and 6. So in order to know if it is disjoint or overlapping, we see if there's anything that these have in common. And if you notice, there's a 6 they have in common. Those 6s would overlap. So we would call this overlapping. Okay. The other one here is an example. You roll a die and you get a 2 or a 4. Okay. And then the other possibility is that you get an odd number. So is there 2 or 4 that is also odd? If you think about the list of numbers, is there anything that overlaps? Well, 2 and 4 are not odd, so these would be disjoint because they don't have anything in common and they don't have anything that overlaps. So when you're calculating the probability of these types of events, when you're talking about things that are overlapping, okay, that means you have two probabilities and you have to subtract back out that overlapping part because you don't want to count it twice. So in order to count overlapping events, like what we have here, okay, you're going to add your probabilities together and then you're going to subtract out the overlap. Okay, so you're going to subtract out the overlap. That's that blue part there. So things that might overlap, like thinking about a deck of 52 cards, if you had an ace or a spade, okay, you could have aces, you could have all of the spades, but that ace of spades overlaps, so there would be an overlap in there with the ace of spades, and you wouldn't want to count that ace of spades twice in your probability, so you subtract it back out. Okay, and we've talked about other examples of that maybe, but decks of cards are quite often they have you do overlapping events. It's the most common way. So then the next thing is disjoint events. That is basically when one thing doesn't really have anything to do with the other. So in terms of a deck of cards, like if probability of like an ace or not an ace or a 3. There are no aces that are also 3s. A club or a spade. There are no clubs that are also spades. Okay? So when we're talking about these, if you have things that overlap, you have to subtract that back out because you don't want to count it twice. And if they are disjoint, then you can just add the two probabilities together. Okay, so I said one of the more common ways that you do this is with a deck of cards. And so I think it might be worthwhile to spend just a minute here to talk about a deck of cards and what's actually in it. If you know, there are 52 cards in a deck. Okay, so that means that there are no jokers in this deck. We're just going straight 52 cards. There are 4 suits. Okay, and those suits each have 13 cards. So there would be 13 hearts, there would be 13 diamonds, there would be 13 spades, and there would be 13 clubs. Okay, these are both black, and these are both red. Okay, so that's one thing. So there's 52 cards. There's 13 of each suit. Okay, there are 4 of each number. So there are 4 jacks. There are 4 queens. There are 4 kings. There are 4 fours. There are 4 fives. There are 4 6. So there are 4 of each number. Okay. Another, and jacks was just an example, so we're not too worried about actually using jacks, but there's 4 of each number. Face cards, okay, each suit has 3 face cards. Face cards would be the jack, queen, and king, which means there are a total of 12 face cards, because if there's 4 suits and each suit has 3 face cards, there's a total of 12 face cards. So if there's anything else I think of as we kind of go through here, we might just add some of that in there. If you're familiar with the deck of cards, then you should be good. Okay, so we have a card is randomly selected from a standard deck of 52 playing cards. What is the probability that it is a 10 or a face card? Okay, remember face cards are jacks, queens, and kings. So we need to first figure out if it is disjoint or overlapping. So let's kind of go through. I have just some steps here to go through. First question I always think, all right, what's the first thing we want to think about if it's a 10? Well, what is the probability of drawing a 10? Well, how many 10s are there in the 52? There are 4 10s out of 52 cards. So the probability of drawing a 10 is 4 out of 52. The probability of drawing a face card, okay, remember there are 12 face cards, okay? Each suit has 3 face cards. 4 times 3 is 12. So the probability of drawing a face card is 12 out of 52. And then you have to think, is there anything that overlaps? Okay, is there any card that is both a 10 and a face card? Okay, if you think about it, 10s are not face cards, so there is nothing that you can overlap with or anything like that. So there is none. So there's nothing to overlap that overlaps. So that means this is disjoint, which means if it's disjoint, all we have to do is add the 2 probabilities together. So we're going to go 4 out of 52 plus 12 out of 52 is 16 out of 52. And if we wanted to leave that as a fraction, we could do that. You always just have to read the directions on what it wants you to do. If we put that as a percent, it'd be about 31%. So you'd have a about 31% chance of either drawing a 10 or a face card. Okay, so let's look at another example. All right, same 52 cards, right? We want to know the probability that it is a face card or a spade when you draw that card, okay? So first we ask ourselves, what is the probability that it's a face card? Well, we know there are 12 face cards out of our 52, okay? Spade's one of our suits. There are 13 spades, ace through king, out of 52. Okay, so that's the probability of our spade. What is the probability that it is a spade and a face card? How many cards are both spades and face cards? Okay, so you'd have the jack of spades, you'd have the queen of spades, and the king of spades. Okay, so there are 3 of them that are both a face card and a spade. So those 3 are the ones, the 3 out of 52 that you can't count twice. So you're going to go ahead and subtract it back out. So you'd have 12 out of 52 plus 13 out of 52. You're going to add those 2 probabilities together and then subtract out the overlap, which gives us 22 out of 52. If we wanted to leave it as a fraction, we could. If we wanted to put it as a percent, that'd be about 42.3% chance that if you picked a card, it would be either a face card or a spade. All right, let's look at one more here. All right, our last, oh, we have 2 more here. If you want to go ahead and pause the video and try them on your own and see if you can get them correct, and then listen to the rest of it and make sure that you're on the right track, that would be fine. If you just are still wanting to listen for a little bit and see a couple of examples, that's fine. 52 cards, an ace or an 8. Okay, so first thing, what's the probability of an ace? Okay, there are 4 aces out of 52, plus the probability of an 8. There are also 4 8s out of 52. Then is there anything that is an ace and an 8? There's no overlap here, so there's nothing to subtract back out. All the ace, there's only 4 aces and there are 4 8s. There's none of them that overlap. So that means we're just going to add our probabilities together, and we would have 8 out of 52. And if we left it as a fraction, or we could go ahead and change it to a percent, which is about 15.4% chance that if you selected a card, it would be either an ace or an 8. Okay, last one here. We have the probability of a 10 or a diamond. Okay, well, what's the probability of drawing a 10? Well, there are 4 10s out of the 52. How many diamonds are there? Remember, each suit has 13, so there are 13 diamonds. And then you do have, how many cards do you have that are both a 10 and a diamond? Well, that would be the 10 of diamonds, and there's only one that is both a 10 and a diamond that you would need to subtract back out. And then luckily it's nice when we have these fractions because everything is common denominator already. So we would have 16 out of 52. And if we wanted to, we could change that into a percent, which is about 30.8%. So if you picked a card, you'd have about a 30.8% chance that it would be a 10 or a diamond. So we're just going to have you do some practice on this independently. Please let me know if you have any questions.